Hello, my name is Katharine Bernstein, and today I'll be working through topic problem 93 from chapter 13. This problem can be found on page 617 of our textbook. This problem reads, a 1.2 molality aqueous solution of an ionic compound with the formula mx2 has a boiling point of 101.4 degrees Celsius. Calculate the Van Hoff factor, I, for mx2 at this concentration. I think the best way to begin approaching this problem is to figure out what equation we're going to have to use. Now first, we know that we're calculating the Van Hoff factor, which is only in two different formulas that we know, one for boiling point elevation and one for freezing point depression. Since we are given the boiling point of this solution, I'm going to assume that we will be using the equation for boiling point elevation. So I will write the equation delta T boiling equals I times the K boiling constant times molality. Now I'm going to start writing all the information I know that was given to me in the problem. Now to solve for delta T boiling, I'm going to write 101.4 degrees Celsius minus 100 degrees Celsius. Now I've come up with these numbers because that is the boiling point of our solution minus the boiling point of pure water, our solvent. Next, I'm going to write down the K boiling constant for pure water, which if I look in my lecture notes, I can see is 0.512 degrees Celsius over molality. One piece of information given to us by the problem is the molality of the ionic solution, which is 1.2 molality, or moles of solute over kilograms of solvent. Finally, the focus of this problem is to solve for I, the Van Hoff factor, which tells us the number of ions or particles in the solution. Now that we've defined all the elements of the equation, we can input the values and begin to solve for I. Remember to include the units for temperature and molality, as this will be helpful in keeping track of our math and determining the units at the end. First, I will begin by solving the left side of the equation, 101.4 degrees Celsius minus 100 degrees Celsius, which gives us 1.4 degrees Celsius. On the right side of the equation, the variable I will stay the same. Next, we'll multiply 0.512 degrees Celsius per molality times 1.2 molality. It's critical to notice that our units for molality cancel each other out, and we'll get 0.6144 degrees Celsius left on the right side. In order to isolate I, the Van Hoff factor, I will divide both sides by 0.6144 degrees Celsius. Again, the units degrees Celsius on the right side of the equation will cancel each other out, which is important since the Van Hoff factor doesn't have any units. And on the left side of the equation, we will just be left with I. From my calculator, I get a number with a pretty long decimal, 2.278646 as the value of I. Now I will determine the number of significant figures that I can have in my final answer. If I look back at the information that was given, I can see that I'm only given two significant figures for the molality. So this will be determining the number of significant figures I can have in my final answer. So I will round my answer to 2.3 as the value of I. So let's review how we solved this problem. First, we wrote down the equation we knew we were going to have to use. Then we figured out the change in the boiling temperature, which was the boiling point of the solution minus the boiling point of the pure solvent. We wrote down the known value for K boiling of water and the molality as it was given to us in the problem. With all our variables defined, we input the values into our original equation and solved for I. I hope this video has been a helpful resource in how to work through a boiling point elevation problem.